Good day, Dr. Afshari. Today, Group 4 will be presenting Metaverse in Supply Chain. I'm joined today with Andrew Swift, Megan Greenwald, Jacob Pierce, and Pikai Sun, and my name is Alexander Culberson. This is today's agenda for the Metaverse in Supply Chain.
So, what is the metaverse? The metaverse is a collective of virtual space where users will be able to log in and interact with artificial intelligence and other users in real time. It is becoming the future of online interacting in various capacities. Currently, the various sets of metaverse worlds have their own access to them. Down the line, it is foreseeable that a single login will grant access to the entire verse. Uses of the metaverse include social interactions, education, business, entertainment, healthcare, real estate, training, and communication.
Industry 4.0 is the newest industry revolution that is integrating digital technologies to optimize industry process. It aims to improve productivity and lead into a smart industry. The metaverse is a convergence of physical and virtual space, interconnecting network of virtual space beyond industry-specific application, compared to the way that Industry 4.0 aims to improve in a specific industry. Some people often confuse them because they both use similar digital technologies such as Internet of Things and AI. These have very different uses, where Industry 4.0 uses AI for predictive maintenance, quality control, and process optimization. The metaverse uses it for use such as creating intelligence entities and realistic simulations.
The metaverse has diverse applications in supply chain management with its common components or main components, big data and analytics, Internet of Things, digital reality, digital twins, artificial intelligence, and blockchain contributing distinct technological advancements. Big data and analytics enhances supply chain efficiency by expediting information processing and forecasting, thereby reducing risks and uncertainties. Internet of Things enables real-time object tracking, facilitating improved visibility and communication across supply chain stages. This technology is useful for customers while tracking their orders. Digital reality, a major component of what is commonly perceived to be the metaverse, offers a virtual platform for realistic simulations, applicable in scenario testing, employee training, enhancing transportation safety, and elevating stakeholder and customer experiences. It's important to note that digital reality encompasses augmented reality, virtual reality, and mixed reality. Augmented reality enhances warehouse, facility, and transportation functions, improving operations and safety. Virtual reality, frequently used for employee training, significantly enhances stakeholder experiences. This multifaceted integration of metaverse components optimizes various aspects of supply chain management, driving efficiency and innovation. Digital twins is another emerging suite of technologies often integrated into the metaverse. Or approach involves real-time monitoring of systems using a set of sensors and tracking devices, collecting data from individual components and utilizing a platform to model the system in real time. The technology facilitates daily activity planning through real-time simulations, thereby enhancing the accuracy of outcomes. Artificial intelligence, when combined with real-time data collection technologies, is a very powerful tool for decision-making and problem-solving. Its smart and unbiased capabilities, driven by learning from data, enables faster conclusions than traditional human processes. Finally, blockchain, a robust record-keeping technology, establishes a secure platform for automated transactions and electronic contracts. Its impact on the supply chain lies in reducing errors associated with record-keeping and exchanges and mitigating fraud. This makes it an invaluable tool for monitoring activities across the supply chain, an environment where numerous transactions unfold. So these six technologies are frequently employed together to harness their collective potential. When this occurs, it can be referred to as the metaverse. Digital twins, for instance, can often be paired with big data and analytics and artificial intelligence. This combination enables seamless collection, analysis, and real-time interpretation of data and simulations, empowering businesses to be to make more informed and intelligent decisions. On the other hand, virtual reality has the capability to integrate with any of these technologies, enhancing user experiences by providing more realistic depiction of system scenarios. This collaborative utilization of technologies not only amplifies their individual capabilities, but also fosters a comprehensive and dynamic approach to solving complex business challenges.
The impact of the metaverse on supply chains is multifaceted, with implications at tactical, operational, and strategic levels. At the tactical level, the metaverse enriches our experience by providing stronger tools to navigate seismic events that can affect data gaps. Real-time data optimization enhances decision-making and transparency, enabling more informed and agile choices. The metaverse also streamlines the procurement process by allowing sourcing to be done virtually, where new suppliers may offer interactive experiences and or virtual showrooms. The metaverse can also integrate synthetic data to provide more effective planning and forecasting rather than applying historical data that can lead to data gaps. Operationally, this new technology fosters new behaviors and markets, facilitating more effective collaboration across all levels within the supply chain. Information synchronization allows for better responsiveness and a more reactive supply chain. Operationally, the metaverse offers a more streamlined production process by using the digital replication of materials and products to better allocate resources across facilities, reducing disruptions, downtimes, and changeovers in plants. On a strategic level, while the metaverse addresses existing challenges, its full potential requires further research and development. Organizations that proactively incorporate the metaverse to anticipate disruptions in traditional business models are poised to become industry leaders. The metaverse offers organizations the opportunity to have deeper manufacturing with real time visibility across the chain, reducing returns and allowing for a more efficient process. On a strategic level, warehouse design is impacted by the metaverse as it can plan and design a warehouse, simulating flow and finding critical areas before a physical structure is pursued. Overall, the metaverse introduces a heightened level of interaction on both operational and strategic fronts, with increased information sharing, synchronizing all stakeholders in real time. The integration of a metaverse based platform into supply chain management holds the promise of transforming operational efficiency, safety, and productivity. With the ability to provide valuable insights into lead times, durations, and real time costs, this innovative approach positively impacts the bullwhip effect throughout the entire supply chain. The platform's capacity to simulate the complete supply chain in 3D and showcase manufacturing, storage, distribution, and sales processes in real time enhances visibility and accountability. Moreover, it fosters a more interactive relationship with customers, offering improved insights into buying and selling processes while boosting overall responsiveness. On the front of safety standards, the metaverse significantly influences all employee levels by offering effective training through digital reality at affordable operation costs, resulting in a safer work environment. Additionally, the immersive training experience contributes to the reduction of product failures and waste, while also enhancing machine operation capabilities for executing more complex tasks. Beyond operational aspects, the metaverse based platform contributes to sustainability by minimizing trash production, allowing organizations to identify opportunities for waste reduction, lower energy consumption, and decrease environmental impact. In essence, the metaverse emerges as a multifaceted tool, not only revolutionizing supply chain management, but also fostering safety and sustainability within the business landscape. While the metaverse offers transformative potential in supply chain management, several significant disadvantages must be considered. One major challenge is the lack of standardized application in 3D virtual world, leading to potential interoperability issues among different metaverse platforms. Intel's estimation of the need for substantial improvement in computing power highlights a potential digital divide, where organizations lacking access to advanced computing may face challenges in collaboration within the supply chain. Additionally, the metaverse is susceptible to sharing real world pitfalls, including inequalities within its ecosystem and ethical concerns such as job displacement. Security is a paramount overarching concern, as centralized metaverse networks pose a risk of catastrophic effects during system failures. And the introduction of more technologies may increase the likelihood of glitches and network issues, posing potential threats to the integrity of the supply chain.
Exploring the many advantages of integrating the metaverse into supply chain prompts the question of which stages are most deeply impacted by its application. To begin, let's consider the downstream stages encompassing wrong slide. So various analytical and mathematical models have been developed for the application of the metaverse in supply chain management. In the context of this presentation, it's essential to highlight a model specifically designed to identify and quantify bottlenecks in implementing the metaverse within the supply chain. Covariance-based structural equation modeling, or CBSEM, and artificial neural network modeling, or ANN, are two statistical models employed for precisely this purpose. In a comprehensive study, both models were utilized to pinpoint the primary factors hindering the effective integration of metaverse technology into supply chain operations. A key finding was that a company's technological limitations emerged as the most significant contributing factor, highlighting the importance of addressing these constraints for successful implementation. Also, the models identified issues such as a lack of governance and standardization, traditional organizational structure, insufficient stakeholder commitment, limited collaboration, and a low perception of value by customers as significant factors diminishing the potential benefits of metaverse applications. Supply chain managers and researchers should consider these factors when exploring new models, approaches, and implementation strategies for the metaverse. For those interested in the mathematical formulation of this, it's worth noting that surveys were served as inputs for these models and were validated using supplementary statistical methods. The CBSEM model identifies linear relationships within survey trends, while the ANN model can uncover both linear and nonlinear relationships. So this provides a comprehensive understanding of the complex system dynamics involved. So when we explore the advantages of integrating the metaverse into supply chain management, this prompts the question of which stages are most impacted by its applications. To start off, let's consider the downstream stages, encompassing retailers and end customers. The metaverse positively impacts these stages by enhancing visibility through real-time updates and object tracking facilitated by Internet of Things and big data. Additionally, digital reality contributes to this positive shift, offering customers and retailers more interactive interfaces and personalized digital services. A good example is the virtual showroom, shown similar to this picture on the left here, which provides an innovative platform to showcase new products. The enhancements brought to the table by Metaverse in the downstream segment of the supply chain creates a unique and responsive experience for customers, likely resulting in an increased demand for products and services. So when we consider the upstream stages of the supply chain and the corresponding impacts of the metaverse, we also improve responsiveness on the end customer. And Metaverse seeks to improve supply chain efficiency through logistic enhancements. This optimization is improving forecasting accuracy, which is made possible through a combination of advanced analytics, artificial intelligence, and enhanced visibility between stages. Smarter decision-making concerning transportation and inventory, facilitated by various metaverse components, further contributes to this efficiency. In essence, the metaverse yields substantial positive impacts, not only in the downstream stages, but significantly influences the upstream stages as well. An important concept in this context is the bullwhip effect and variance acceleration. In broad terms, as the upstream segment of the supply chain develops superior forecasting capabilities, the variance in order quantities diminishes, resulting in an overall more efficient supply chain.
So, implementing the metaverse. To implement big data and analytics in a supply chain, it can be done by connecting market information up and down the supply chain, such as demand forecasting to determine production or determine hiccups in inventory management to influence the pricing at retailing and as well as the production. Internet of Things is implemented in a supply chain by connecting the whole system with relevant bookkeeping and management information, enhancing visibility and becoming easy to access information, and increasing efficiency with less human hands in the system as humans add variance. Digital reality can be implemented by bringing physical spaces to members of a supply chain digitally, but also creating digital elements to physical spaces. This can take the form of virtual storefronts or operational instructions in the form of augmented reality. Digital twins are implemented in the form of digital replicas of spaces or equipment. This can be used to simulate the changes to the supply chain, a new supply chain, or how to aid in training of members in a supply chain. AI can be implemented through predictive analysis to prepare for changes in demand and hiccups in inventory management at speeds greater than humans can calculate with predictive analysis. And blockchain is implemented to aid in the accountability to be used as confirmation that a task has been completed or performed, or a legitimate product or material has transferred between hands physically.
Here's some successful examples of metaverse implemented in supply chain. First, car maker Hyundai is partnering with Unity to jointly design and build a digital twin of an entire automotive factory. At this new facility, Unity will work with Hyundai in the intelligent manufacturing, integrating artificial intelligence, 5G, and other advanced manufacturing technologies into the auto factory floor. This factory would aggregate data from products, process, and staff to create an evolving digital profile based on historical and current behaviors. As a result, the factory operator can more accurately predict and plan for possible outcomes. The metaverse will also allow Hyundai to test run an entire factory virtually to optimize plant operations. Factory managers and operators will also be able to solve problems remotely. Additionally, NVIDIA Omniverse is the same idea developed by NVIDIA and currently used by BMW and Siemens for virtual collaboration. More examples are like DHL has used industrial metaverse for supply chain simulation, allowing them to optimize their logistics process and reduce costs. Honeywell has also used the industrial metaverse for the simulation or the optimization of its industrial process, as well as for virtual demonstration of its products to customers. There are many other companies working on bringing metaverse into their supply chain for similar purpose. This instance collective effectively demonstrate the Metaverse transformative impact on optimizing workflows, fostering collaborations, and driving efficiency across the supply chain spectrum.
So this slide presents some recommendations that we've developed for both supply chain managers and for supply chain researchers. So first off, we believe that before implementing metaverse technologies, based on some of the limitations and challenges we discussed in this presentation, we think that it's necessary for any manager, any company, considering or implementing metaverse into their supply chain or into their company. It's really important to first assess the current technological infrastructure they have available, and actually determine if it's feasible or economically viable to implement it. So they need to determine if, if the upgrades are required, if the return on investment is attractive for the metaverse. Additionally, we believe that it's important to develop a structured implementation plan so the technology can be used effectively. One of the main challenges was not having engaged stakeholders and employees, or even customers that are interested in using the technology. So it's really important to get people engaged and develop a plan in order to do that appropriately. On the other hand, for supply chain researchers, and this aligns with what we discussed in class, we believe that it's really important to prioritize researching concepts related to sustainability. So it would be very useful to explore topics related to how metaverse can improve sustainability in the supply chain, which there would be many applications of. Also, it's important to consider metaverse solutions and applications that require minimal technological infrastructure to be inclusive to all companies. So here we really want to highlight, we really want to address the challenges associated with metaverse and supply chain, and the top one being technological limitations. So it's important to consider that in research. Here are our references, or a few of them. Yeah, so thank you for listening. Yeah, thank you.